Elements are the basis of everything we know. Each element can exist in a number of different forms, and these different forms are called isotopes. Isotopes of a single element all act in the same way. However, they have differences in weight, and this is because they have different numbers of neutrons. On the periodic table, we know oxygen to exist as 16O. This is the dominant isotope of oxygen, but actually there are two additional forms of oxygen. There's 17O with 9 neutrons and 18O with 10 neutrons. And in science we can measure the proportion of one isotope in comparison to all the others. Now this is called the natural abundance. Now the proportion of these different isotope ratios exist in absolutely everything, and they can change wherever you are in the world due to a number of different factors. Let's look at oxygen again, but this time in water. The ratio of delta 18O in water varies in different locations due to climate and altitude. We're able to measure these differences and plot them on a map known as an isoscape.
But how does this affect me?
When we drink water or cook with it, the delta 18O isotope composition of that water becomes incorporated into our body and reflected in our tissues. One example of this is the protein keratin, which makes up our hair and nails. These two tissues grow continually over time. When you go on holiday, or change location, or drink just different water, our body will incorporate that different delta 18O value and show that change. The data obtained from our nails can date back to water we drank 6 months ago. That's how long it takes for the newest of the formed layers to travel up the nail plate and reach the white bit at the top. If we use keratin proteins close to the hair follicle on the scalp, we will receive isotopic information of water from recent times. But the keratin right at the end could be related to water we drank up to 3 years ago. If you want more information, what you could do is measure oxygen from bioapatite, the substance that makes 97% of the enamel, the outer layer of our teeth. Take a look. The enamel of our adult teeth actually forms in layers underneath the baby teeth that we already have in our gums. The delta 18O that can be seen from teeth actually reflects informations and locations from when this enamel was forming. The time period reflected by teeth varies because they all form at different stages of our life.
Couldn't you just ask them where they're from?
What kind of question's that? Obviously you could ask them. But what if they were dead? Roll VT. Imagine this, with detectives. Currently, work is very stressful. There are 3 missing men in the local area and we have no leads. We'll go for a walk in the woods to clear our heads.
Is the camera on? Look, quick. There's a body. It's been dismembered and burnt. It could be one of our 3. Ideal. From close inspection, we can tell this once was a male. The killer's been quite unhelpful. The body's been dismembered, torched. We need to kind of figure out if this once was one of our 3. We can't do fingerprints or facial reconstruction, but we do know about isotope analysis. So we'll take some samples and we'll take this to the forensics department.
Oi, I've told you before.
Here are the hair results, sir.
Thank you. After studying the isotope ratios of oxygen from hair closest to the root, we can determine that the oxygen isotope ratios obtained are actually consistent with the local area. Mr. Taylor, he's recently been to Mexico, a luxurious, luscious location. Because he's in a warm climate, the delta 18O would have been increased. Therefore, we can eliminate him from the process of possibilities. Sorry, mate. No idea where you are. Now we're just waiting on analysis of enamel.
Here you are, sir.
Thank you. Following isotope ratio analysis of oxygen in enamel, we can confirm that the obtained delta values in 18O are actually consistent with water sources of the Mediterranean. As enamel is formed when we're a child, we can interpret this data to suggest that these remains do in fact belong to someone that's from the Mediterranean, therefore disregarding Connichelli after all. We could presume that it is the Italian stallion himself, Joseph Calecchia. However, we need to somehow prove this. Mr. Calecchia moved to the UK to be a good dad. Perhaps we could do a DNA paternity test of both the boy and the dismembered body to see if the deceased was once his poor boy's papa. The results are in, DNA paternity test is back, and we can confirm that the body is the biological father of the son, confirming that Joseph Kalekia, you are dead. And overall, isotope analysis can aid in human identification.
Any further comments?
I guess you could say you are what you eat.